Shelby Switzer. As Graham said, I work for a company down in Denver called Notion. We make home sensors that are incredibly smart. They can tell you if a door opened and you're not home, if you have a water leak, what your temperature is. They can detect ambient light, and they do a bunch of other stuff. And at Notion, I work on the API and some of our web services. And as you can imagine, being in the Internet of Things, we deal with lots of data, tons and tons of logs, and distributed systems. But today I'm not going to talk about any of that. I'm going to talk about a project that I work on called API in a Box. And it essentially works with small data. Because the world runs on small data. And I think that as developers, we sometimes forget that most people in their daily lives work with Excel spreadsheets and CSV files, and they don't really have the problems of having to understand accelerometer data and know what to do with it. And a perfect example of the world running on small data comes up in civic hacking all the time. In my free time, I like to work with Code for America brigades. Civic hacking is how I got into programming years ago in South Carolina. And then I moved to Atlanta and worked with the Code for Atlanta brigade there. And now that I'm in Denver, I work with the Code for Denver brigade a lot. And small data is always a roadblock. And it's not even necessarily about getting the data, which you might think is the hardest part, but it's about what to do with the data once you have it. So to illustrate, I'm going to tell you a story from Atlanta. We worked on a project called Show Me the Food. And essentially, the Code for America brigade, Code for Atlanta, had a really good relationship with the city of Atlanta, as well as the Atlanta Food Bank. And so we were looking for projects to really help the food bank solve critical food issues in the city. And one of those food issues is food deserts. It's a major problem in Atlanta. It's a major problem in Denver. So the brigade, as well as the Atlanta Food Bank, wanted to find a way to identify food deserts and map them out, and then also build a canvassing tool to allow people in the community to go into a food desert. Maybe they live in one, and they go to a convenience store and they say, well, hey, this is just a convenience store, it's just a 7-Eleven, but they have fresh produce. So then you can start to map out where you actually have fresh produce as opposed to just convenience stores. And before I go any further, does anybody know what a food desert is? Or does everybody know? So a food desert is where you have a giant swath of land or area where people live, but they do not have convenient access to healthful food decisions. So for example, they can't access vegetables to have a nice dinner. They have to go to fast food places or convenience stores and cook ramen. So after we do the canvassing tool and we identify these food deserts and we identify what's actually in these food deserts, we wanted to visualize the findings and ultimately change the world, or at least our small part of it. So where do we start? This is our data. It's 2 CSV files that we got from the city. The top one is a CSV, it's a tax digest, essentially, of all the businesses in the city. And the bottom one is a statewide list of businesses that accept EBT, which is similar to food stamps. So as you can imagine, there's going to be duplicate data between them. They're also from 2 different governmental organizations, so the data is completely different in format. You can't really trust that any of the data is standardized or consistent, or even typo-free. So when we got this data, we had to figure out what to do with it. Like, where do we keep it? How do we interact with it? Do we normalize it? Do we dedupe it? What database do we use, if we use a database? As you can imagine, being developers, we all had really strong opinions about all of this. And the project sort of stalled because we didn't really know exactly what to do with the data. And once we knew what to do with the data, we had to then start building on top of it, and we're all from different backgrounds, so we have different environments and different skill sets. So organizing all of this, in general, is just a huge issue for civic hacking, and it's something that we really try hard to overcome. So in the process of this project, as well as lots and lots of other civic hacking projects, we've identified really 5 big needs when working with government data. The first is that we need an easy and free way to store and maintain the data. We also don't really want to change the data. One of the conversations that kept coming up was, why don't we just pull the business name, the latitude and longitude, and then just be done with it and like ditch the rest of it. But just because we only need those details for our use case doesn't mean that the other columns won't be useful for other people who want to interact with this data. So we didn't really want to change the data. And we also need to integrate or have a flexible and robust API to make the data not only accessible, but also easy to interact with and flexible. And we also can't have it hosted because we don't have any money. We're just doing nonprofit stuff. And we need to be able to set it up simply on any server or any computer for anybody who comes and gives up their Tuesday night to come hack and doesn't want to spend the entire night installing Postgres. So the first step, just maintaining and storing the data, is just a simple solution. Just pop it in GitHub. The data is open anyway. It belongs to the people, so there's no reason why it can't be in an open repo. And it's free. And we all know how to work with it for the most part. And it's much better than passing around a thumb drive, which is what we were doing. And then, once we want to actually interact with the data and get it into our environment, what do? We need to put it in some sort of local data store, probably, to make it easier to interact with, as opposed to just through the GitHub API. So we chose ElasticSearch as our document store for these CSV files, or the rows within CSV files. It's schemaless, so we didn't really have to try and force things into tables. It's also just JSON documents, and most web developers are pretty familiar with working with JSON, as well as a RESTful API, which is what ElasticSearch provides. And it also has really powerful search capabilities, which was really key because we have to be able to search and understand data that's not normalized, that has typos, that goes from being integers to strings to floats. And so ElasticSearch really provides a lot of functionality around that. So we do a little bit of work on top of it. So when we dump the data from the GitHub repo into ElasticSearch, we essentially do the mappings. So mappings are essentially the columns of your data. So we have name, lat, long, business type, and then we add a metadata field of file source, so we know which CSV file this data is actually coming from. And we also want to keep everything as strings. So in Elasticsearch, there's loads and loads of different data types, but because we can't really guarantee that any column is going to consistently be an integer, we can't really use that data type. So we just keep everything as strings. So far, we have solved two of the needs, which is that we have an easy and free way to store and maintain data, GitHub, and we don't change the data, and we just basically keep it in Elasticsearch with some metadata added to it. And now we're on the way to getting a flexible and robust API. Elasticsearch kind of provides the functionality underneath that. So this is where Ruby comes in. We just spin up a simple Sinatra API on top of it, which makes things really easy. And then we also need to do a little bit of work to make this API really fun to interact with. We want to make it self-descriptive. We want to have lots of metadata attached to the data that we're getting, which is where collection JSON comes in. So I'm not sure how many people here are really familiar with using hypermedia types in their APIs, but collection JSON is a fantastic one for describing collections of data and formatting representations of those collections. It's written by a guy named Mike Amundsen, who does a lot of work in the REST community, and essentially allows us to create a standardized format for reading the data and getting metadata about our resources. So if we just walk through it, we have this top-level object called collection. We get the URL for the collection, which is just resources, after my Docker IP import. And then we have an object called items, which is just the array of all my resources. And each resource has its own unique URL, as well as the data associated with it. So this resource here, I have Bob's Convenience Store with this lat and long business type, and also the file source that it came from. But in addition, what makes this really powerful is that we have this secondary object below called queries. And essentially, it just takes my Elasticsearch mappings, which come from my CSV column headers, and provides them as query parameters. So I can start to search based on name, lat, long, or business type. And I don't even need to know about the original CSV file. I just know that these are now my possible queries because it's been given to me. And I don't even need to know what my raw original data is. And then I can also start to add meta queries on top of that to start to really utilize Elasticsearch's functionality, such as dedupe, which will just do some field collapsing on Elasticsearch's end. I can dedupe by name, or I can dedupe by any of these queries, which makes it more powerful than just presenting raw data. So now I've scratched out my API requirement. So how do I go from here? How do I make this solution portable and free, where it doesn't need to be hosted but can still be replicable? Well, that's where Docker comes in. So Docker is super hot and trendy, and we use it all the time at Notion, and maybe lots of you use it too. But Docker is really, really useful in the civic hacking space when you're dealing with loads of different people with different environments. And now all they have to install is Docker, as opposed to installing Postgres, installing Ruby, installing a Ruby version manager. And we can just have Docker and suddenly have all of our API functionality contained within a Docker container. So how does this work? How do all these pieces fit together? Essentially, it looks like this. You just put the data in GitHub, and then when you spin up your Docker containers, it runs a rake task that grabs the data from the GitHub API, dumps it into an Elasticsearch index with the appropriate mappings and any other metadata that we're adding. And then we have this Sinatra API on top of it in its own container that provides these hypermedia responses. And I like to use Docker Compose for this, meaning that I can just spin up all of this stuff with just Docker Compose up. This is what the compose file looks like, just specifying my API container as well as my Elastic container, which is just using a base image, and exposing my ports appropriately. And these are the steps. You throw the data in the GitHub repo, you pull or you build a Docker image locally, and then you just do Docker Compose up, or you do the Docker run command, and you just specify the origin repo of the data that you're pulling. And then you can begin to curl on it, or use whatever library to access it by HTTP. So I can start to curl on my local host or my Docker IP, just /resources, so my resource name never actually changes. It's not going to be /businesses or /organizations. It's just always going to be resources, so I know the API DSL, and I can start to dedupe it, or I can use any of these other queries that have now been exposed through the hypermedia format. So now I've suddenly gotten rid of all my requirements, easy and free to store and maintain the data, little or no changes to the raw data, flexible and robust API, and it doesn't need to be hosted, and anybody can be setting it up. And one really powerful aspect of this is just that if we're working with this data and it's not hosted, we're still using, if I have got 10 people in a room together, and we're all working with this data and building an iOS app to build this canvassing tool, we can still all work with the same data with the same exact API, and it doesn't have to be hosted anywhere, which is really powerful. So I would just like to ask you guys to get involved. I know that the daily grind really takes a lot out of us, but maybe help me with my project, or just find your local brigade and start getting involved in the community and start solving problems that really actually affect people's lives in a more direct way and your own community. So, thank you.